these things, what we have concluded, we need to do some kind of a keys actually. Okay, we need to use some kind of a key to actually achieve all these things. And these keys are key management. How we can manage those key? We can generate a key ourselves. Okay, normally if you are living in the same house, you have the same key, I have the same key, we go outside, we get the key, new key or duplicate key from the key generator or key creator outside, or maybe sitting somewhere, he has a shop. But how we normally in the digital world, in the digital format, in the computer format, computer world, actually there is no such way we can do. It will add more time actually. There was a time when you share the secret key or all those things. But how we can generate a key, then other party can verify that we are using the right key. What is the method of key exchange, where we can key store, what should be the length of the key, how long the key should be valid for. And another important interesting thing is when we can revoke the key and destroy it. So in the day-to-day life, wherever we are living, we use the key, like we can create a duplicate key. However, in the digital world, in the internet world, where the delivery of the method or the message is very, very important and quick, we want quick turnover. So it's not possible that we use, like, I give you the key, you give the key, and we get a duplicate key. So there must be some kind of a method or procedure where we can agree how the key will be generated, how we can send it and verify that the key is the same. What will be the method to key exchange? Okay, is it a manual method? Is it some kind of automatic method? Key exchange, how we can exchange those key, where we will be storing the key, what will be the lifetime? Lifetime will be 1 day, 2 day, or forever. And once the keys are revoked, if they no longer be used, we can revoke them and destroy them as well. And then key space. So normally you can see this is the, for example, AES. It's an advanced encryption standard used since 2001. Is a symmetric key. Okay, and these are the length of the key can be high, speed is high. So if you want to break that, you might need 149 trillion a year to AES, and resource consumption is low. So these are some of the characteristics of the key we use normally nowadays. So when we say, for example, the DES, we use the encryption, we use DES for the encryption. 56-bit mean 2 raised to power 256, 57, and 60. Okay, possible key. So these are the possible key can be generated with the using these key length. So some of the type of the keys actually symmetric key, asymmetric key, digital signatures. Symmetric key means both the keys are same. Asymmetric key, the keys are not both sender and receiver, they have the different keys actually. Digital signature, we will see in a minute. Hash the keys as well. So key will be sending through the hash as well. Types of the key. So here you can see, for example, how these are protection for up to 3 years, symmetric. Okay, asymmetric, digital, hash 160. These are the length of the keys actually. Okay, and if you want to break this key with the quantum, so these are the time you need, a protection up to 30 years and so on. So these are different values we can see. How we can choose the key? Shorter key, faster the process. So as we said, if the key length is small, of course it will be more easier to process it. But the issue is it's less secure. Okay, so if you're using 56 key length, for example, it is much faster process, less CPU intensive. However, it is, but it is less secure on the other side. Longer the key, slow the process, no doubt, but it is more secure. But it will take more CPU as well. Keep in mind, more resource intensive. Okay. Okay, so this is the confidentiality is finished.